right, congrats. We have gone through 3 of our transformations. Our last transformation is the dilation. Remember that dilation is the transformation that changes in size. So it can go from small to big, or it can go from big to small. And in order to do that, we're going to be multiplying by a scale factor. You might remember the word scale factor from when we did measurement, when we were talking about increasing the volume by, or increasing the height of something by a scale factor. Say we multiplied the height by 3, the volume would also increase by the same scale factor, which would multiply by 3. So there is some relationship between those two concepts. Okay, so a dilation is a transformation in which a shape gets bigger or smaller, like I just said. We are given a scale factor to multiply each coordinate by in order to perform the figure's transformation. So as we look at number 1, it says use the scale factor to dilate the figure, and we're given a few steps to follow. So step 1, fill in the original coordinates in the table below using the graph to the left. So here's our graph. We have a nice little rectangle, so we're going to go ahead and label the coordinates. So the original coordinates for A, we're moving over 1 and up 4, and it's all in the first quadrant. So remember, anything in the first quadrant is going to be positive. Okay, and then let's see B. B moves over 1, 2, 3, 4, 5, over 5, and also up 4 since it's right across from A. C, that point is just 1, 1. And then we have D, and that point moves over 5 and up 1. Okay, so those are our original coordinates. We do have to know those in order to actually do the dilation. So step 2 says using a scale factor of 2, multiply each x and y, so each are the coordinates, of A, B, C, and D, and write the new coordinates. So what we're going to do is we're going to take the x, which is 1, and we're going to multiply it by 2. Okay, and what would that give us? That would give us 2. 2 would be my new coordinate, my new x value. Then we're going to take the original y, which is 4, and we're going to multiply that one by 2 as well. So 4 times 2 would give me 8. So my new coordinate for A prime would be 2, 8. Okay, if you need help or you don't understand where I got those numbers from, please raise your hand and just ask. You should probably see the process, though, as we go through the next 3 coordinates. So if you look at B, my original coordinates were 5, 4. So we're going to take the original x, which is 5, and we're going to multiply it by 2. 5 times 2 would give me 10. Then we're going to take the original y, which is 4, and multiply that one by 2. 4 times 2 would give me 8. So my B prime coordinates are going to be 10, 8. Okay, now look at C. C is 1, 1. So you're just taking x, which is 1, times 2, and y, which is 1, times 2. 1 times 2 is 2. 1 times 2 is 2. So my new coordinates would be 2, 2. Okay, and then that D, 5, 1. X is 5. So we're going to do 5 times 2, and y is 1. 1 times 2. 5 times 2 gives me 10. 1 times 2 gives me 2. All right. Now step 3, plot the coordinates of the dilated rectangle. Don't forget to label it. So since we're multiplying by a whole number scale factor, my new rectangle should be bigger than my original. If that scale factor is a fraction, which you'll see on the back, yes, we would get a smaller rectangle, but 2 is a whole number. So let's go ahead and plot our new coordinates. So we have 2, 8. So we're moving over 2, and we're moving up 8. Over 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. So you're going to graph your new A, and we're going to label it A prime. And again, probably don't want to draw little dots in your coordinate plane. I'm just doing that so I can show you through the video. Okay, there's A prime. All right, B, 10, 8. 10 is going to be all the way on the outside of the chart, the coordinate plane. And then 8, we would move up. And that's B prime. Okay, C prime would be 2, 2, so we're going to move over 2 and up 2. So that leads me here. Oh, right about there. Oops. And then we're going to label that one C prime. And finally D, which was 10, 2. So that should be right across from the C. And label that one D prime. If you connect the dots of your rectangle, you should get a dilated or enlarged rectangle of the original image. All right, go ahead and flip your paper over to the back for number 2. Okay, this time we have a nice big triangle, and it says use the scale factor to dilate the figure. So step 1, fill in the original coordinates in the table using the graph to the left. So let's go ahead and do that first. So A is 1, 2, 3, 1, 2, 4 over 4. Now we're going into the second quadrant, so anytime we're moving to the left on the x-axis, that is going to be a -4. And then we're moving up all the way to the outskirts of the coordinate plane. We're moving up 10. Okay, so the original coordinates for A are -4, 10. Now let's look at B. B is in the first quadrant, so it should be all positive. Over 2, up 2. So B would be 2, 2. And then C moves over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And up 2, but we'll make sure that's a -10 since we are moving to the left on the x-axis. Okay, now step 2, using a scale factor of half, multiply each x and y of A, B, and I should say C, and write the new coordinates. Okay, so this time the scale factor is half, which is a fraction, so our new coordinates are going to be smaller, and my new triangle will be smaller than the original. So this is an example of how it would get smaller. So let's take -4. We're going to multiply -4 times half. Okay, so you could think of it 2 ways. You could do -4 times 0.5 in your calculator. You could do -4 times 1 divided by 2 in your calculator. Or you could say, well, what's half of 4? Half of 4 is 2, and it has to be negative because 4 is negative. So my new coordinate is going to be -2. Again, you could type -4 times 1 divided by 2 or -4 times 0.5 in your calculator if you wanted. Okay, and then for y, we have 10 times half. 10 times half, half of 10 is a +5. So my new coordinate for A prime would be -2, +5. Okay, let's look at the next one. We have 2 times half twice. Then 2 times half. So what's 2 times half? Well, half of 2 is 1. Okay, and both coordinates are the same, so they're both going to be 1, 1, 1. All right, and then we got -10 times half. -10 times half, half of 10 is 5, so half of -10 is also -5. And then we have that 2 again. 2 times half, half of 2 is 1. Okay, plot the coordinates of the dilated triangle and don't forget to label. So A prime would be over -2, up 5. 1, 2, 3, 4, 5. And we will label that A prime. B is 1, 1. So right here. Label it B prime. And C is -5, +1. So -5, +1. And label that one C prime. Okay, from here we're going to connect our dots. And we make a triangle that's facing the same way, it's just a different size. Same shape, different size, so they're similar figures. Okay, nice job. So what I would like you to do is try number 3 on your own. Get it checked, and then you're going to do number 4 and 5 as well. 4 and 5 are a little bonus, not bonus, they're just a little extension problem that I want you to try. When you are completely finished with that, please see me. Awesome job, you guys.